Welcome everybody to today's PWI Lunch and Learn. A very big welcome to our colleagues from One Big Circle, Anna and Lydia, who are going to do today's presentation. My name is Les McCormack. I'm the chair for the day. I work for Atkins Realis. I've worked here for 20 years or so, and I'm a technical director here. The topic of our talk today is automated intelligent video review technology, digital inspection capability, and monitoring the lineside environment remotely and safely. But before we start with today's Lunch and Learn, just a few pieces of housekeeping that I'd like to go over with everybody. The first is a quick reminder about our 140 challenge. I hope that you're all familiar with the 140 challenge. It's as a reminder, it's we're looking to get a further 140 railway engineers achieving professional registration during this year. If you're at the start of your professional journey, or you just want to find out a little bit more, then we at the PWI are holding professional registration surgeries every other Monday. There are details on the PWI website and LinkedIn page. And the next session is on Monday, the 23rd of September at 12:30 p.m. So the same time as this Lunch and Learn. Please go and check it out. Share it on all your social media networks with your colleagues. Encourage as many colleagues as you can to get involved in the 140 challenge. Now, future Lunch and Learn events coming up to mark your diary are 1st of October, where we'll be talking about slab track systems, AIVR superstructure upgrade during short track possessions, and on the 15th of October, reinforcing rail earthworks in the face of climate challenge. And once again, there are further details on the PWI website and on the PWI LinkedIn page. So today's speakers from One Big Circle are Anna Coates and Lydia Parsons. They will introduce themselves when we start the Lunch and Learn, but just a word on meeting protocol. Please do keep your lines on mute during the presentation. As you've noticed, it is being recorded and it will be available on the PWI social media channels. So it would be really helpful for us if you can keep your lines on mute, and also please keep your cameras off, otherwise you will appear potentially on the video eating your sandwiches or talking to someone in your office or in your room. And the final thing to say is, if you've got questions, our presenters will take questions at the end of their presentation, but please could you post your questions in the chat box as we go along. And at the end, I will round up those questions and we can have a short question and answer session. Thank you very much. So without further ado, I'll hand over to Anna and Lydia, who will introduce themselves and will tell you all about AIVR. Thank you very much.
Thank you, Les. Hi, everyone. Nice to meet you all. Thanks for sharing your lunch with us today. So my name's Lydia. I'm one of the business development managers working at One Big Circle. So I've been with the company for just under 2 years now, and effectively supporting all the ways in which we're developing AIVR and kind of working with the industry to make sure that it suits the needs of its users. I've also got Anna Coates on the call as well. So Anna, if you want to just quickly introduce yourself.
Hi, yeah, I don't know if you can hear me okay before I start talking.
That's fine.
Yeah, perfect. Hi, yeah, so I'm Anna and I work in the marketing at One Big Circle, and I've also been here for a few years. But Lydia will be leading this meeting and I'll be in the chat as well, responding to any questions if they come up as well. So yeah.
Great, thank you, Anna. Perfect. So I'm just going to flip onto our slide just to give a bit of a brief agenda for all those who are joining. So first of all, just want to thank you again for spending your lunchtime with us. We really appreciate all of your insight, and it's great to share sort of all of the different things that are happening within AIVR, and hopefully you'll learn a little bit more about that today. So we'll start with just a brief introduction to the technology and exactly what it is, and kind of how we've been developing it over the last couple of years, but with a key focus on how we're developing AIVR to support your digital journey and exactly kind of what that means, and how that has greater importance within the wider industry. So we've broken that down into a bit of a step-by-step process, which hopefully makes it a lot easier for you and all of your individual team members to understand how the technology can help you and can support your work in a range of different ways and at different points in your journey. So that's kind of going to be the structure for today. And then exactly as Anna just said, we're more than happy to answer any questions you have about the technology and also how we can work with you and work together to enhance your kind of digital line-side monitoring and remote monitoring journey. So just a quick introduction to One Big Circle. There's probably a lot of people on the call who may not have heard of us before. We're a Bristol-based SME specialising in technology with over 120 years of combined experience, specifically in video system design and installation. So we've been working with the rail industry over the past 6 years, mostly through the development of our AIVR technology. Rail loves an acronym, just to spell that out. That's Automated Intelligent Video Review. Hopefully there's some users on the call and we'll go through what that system is and exactly how it works in a bit more detail shortly. But just a bit of background, we effectively develop software and hardware systems in-house from our offices in Bristol. We work really closely and collaboratively with the industry, and particularly with infrastructure owners, Network Rail and Transport for Wales, with a key drive effectively of targeting how we can remove boots on ballast inspections and enhance safety and efficiency across a number of different disciplines in the railway. So that's kind of all delivered through our product line, which is AIVR. So just a little bit of an overview of what that system is and exactly how it works. This is a bit of a high-level map of the infrastructure, but effectively it provides digital inspection capability that allows you to monitor the line side remotely and safely. So from any up-to-date browser, you can log in, find a project location, look at an asset, look at some infrastructure and understand exactly what you're going to be facing whenever you have to eventually go to site. So the way in which that system works is effectively a number of different devices that we've either developed kind of in-house or we've developed in collaboration with our partners. They're installed on in-service vehicles, so whether that be measurement vehicles like Network Rail's visual inspection units or on in-service passenger fleet. We've got a couple of examples down there featuring Merseyrail and also kind of Southeastern. So these devices are installed, and as soon as the vehicle is in motion, we start capturing and collecting critical information. So the video data is all transmitted automatically via 4G and 5G, alongside locational positioning. So you've got all of that kind of positioning metadata, and then it all gets combined and processed in the cloud and made available for you via the AIVR platform. So when you have an AIVR license, you can effectively log in, find a location, and then start reviewing up-to-date imagery over a wealth of different routes and regions. So we also have a number of different mechanisms in which you can interact with that data. So whether it's measuring, making annotations, reviewing reports, you can really get involved with exactly it is what you're seeing and understand your environment without actually having to step through some ballast, which is obviously the key driver. So just a quick overview of the platform. I'm conscious this is the pitchy bit over, I promise. But this is basically just a little bit of context around how the system works. So what you're seeing here is the platform itself. So this is basically kind of a standard user journey. You'll log in, you'll find a location, and then you'll be able to use our interactive network model to basically review any up-to-date data in that set area. As mentioned earlier, you can then kind of interact with that. You can mark up data, you can export that information. There's a whole host of ways you can actually interact with your environment and understand exactly what it is you're being faced with, and also get that kind of site familiarization, which is obviously key where there's limited access. So here we can see we're taking measurements as well and understanding what we might be expecting as part of a site visit, or understanding whether a site visit is even necessary. So we try and basically collate a lot of daytime data to give you the best overview of a location without having to leave your desktop. So that's just a quick insight into how the system works. But what I really wanted to focus on today is how we're developing our AIVR technology to support each and every person's digital journey in rail. So we now have over 8,000 users. The system has really kind of progressed quickly and has had to adapt to all of the different regions and routes requirements, especially with an increased focus on digitalization throughout the industry. So what do we mean by digital journey? I think it's a word that gets thrown around quite often. I mean, We see it a lot in the news and in the headlines. There's a lot of different programs now that we see that are targeting ways that we can kind of harness data and understand how data and kind of big tech can inform more manual processes. So, I mean, I've just been working for the company for 2 years, and understanding the wealth of technology that is available in the industry, it is a bit of a minefield. I appreciate that there's so much specialism and expertise throughout the rail industry. Understanding how we can support that knowledge and maximize it is key to kind of driving the ways in which we can then automate that further with technology. So a bit of a kind of round out view of what digitalization looks like for the next few years. This is just a bit of a summary of some of the focuses on technology in the delivering an efficient rail plan from Network Rail over the years 2024 to 2029. We can see there's a huge driver for building digitalization and maximizing means of using technology to support our industry and support all of the experts that we have available to us throughout the nation. But the key takeaway is definitely that we're increasingly moving towards a data-driven decision-making process. What that looks like obviously depends, and it varies on different routes and regions. But obviously the key drive there being how can we improve safety and push efficiency improvements using all of these digital tools. But there are some things that we need to be kind of hesitant of as well. We don't want to reinvent the wheel. So how can we maximize what we've already got and building on existing technologies effectively? So alongside that, there are some additional challenges, and we understand that different organisations have different needs and different wants for technological solutions. So one of those blockers being kind of introducing new tech has high costs. There are costs of acquiring new and complex equipment, retrofitting existing systems as well. We've seen that kind of in our own work. And also there's obviously that required ongoing maintenance once the system's in place. As well as that, there's obviously a number of different regulatory hurdles. We understand that the industry is devolved and there's a lot of different operating mechanisms that are at play. So ensuring that tech is compliant, safe, and works in the way it should can be quite difficult. And also there's key integration challenges. The system and the systems that are in place have been working well for years and years, but when we start to introduce new technologies, we need to ensure that we're maximizing that data and information and we're not losing any critical insight. We want to be building on that and harnessing that further. So where do One Big Circle come in and AIVR? I think one of the things that we've really realised through working with the industry over the last 6 years is that it's not a one-step journey to digitalisation, and each different organisation is at a different place with where they're using their technologies and wanting to understand how they can use technology more. So what we want to talk about today is how we can support you on your digital journey effectively. So whether that's a case of buying an off-the-shelf solution or actually building something a little bit more bespoke that needs to work with your kind of particular specialisms, AIVR is designed to basically support each phase of that journey and kind of help you deliver the best work that you can. So we've broken that down into a bit of a step-by-step process. So that starts with, there we go, harnessing your data. This is kind of our first stage, and we see there's lots of different ways in which we can do that and work with our collaborators and partners to do so. We then move on to powering up that information and that data using AI and automation and working with other partners to do so. And then finally, looking at how we can actually use all of that information, push that into the day-to-day. So how can we energize those workflows? So we'll start with step one. This is the interesting one, harnessing your data. A lot of different organizations and companies such as operators have cameras on board, they're capturing information, and one of the pushbacks we get often is we already have cameras, we already have data, only to find out that people can't access it, or potentially it's sat on a server for years and it's not doing anyone any good. So how can we actually harness that data and make the most out of it and aggregate it to make sure that the end users and the people that need to benefit from that information can do so in a really efficient way? So just a couple of the ways in which we're working with the industry to do so is actually by building and using our own kind of capture sensors and installations. So we kind of break these down based on requirement and benefit. So whether it's a more portable, low-cost option that needs to fulfill a particular budget or for a particular route or purpose, we have a number of different devices on the left-hand side here. Some of those are mounted externally to vehicles. We can see our AIVR T-Box, which houses 2 different sensors, so thermal and visible. And then also our AIVR Go system, that's designed to be kind of put in place and leave. It's really a kind of encrypted smartphone unit that can sit in any cab window and will start recording upon motion. So really low intervention and can kind of continue onwards in situ. But then also working with our partners to understand where a more robust solution might be needed. So on the right-hand side here, we can see some of our more intensive installs where we're really providing that full monitoring approach and kind of capturing numerous different forms of data, which I'll go into in a little bit more detail shortly. So just a quick overview of the types of data then that you might be able to see as a user of AIVR or as somebody that's interested in boosting your digital inspection capabilities. So starting with forward facing, we've then also got line scanning, thermal video and overline video. So forward-facing video capture, probably the prettiest one. You get some really nice scenic imageries like on the right-hand side here. This is all about capturing the kind of line side environment and giving you that context that you need to understand what work might be required. So we do so again using a number of different devices that are all kind of mounted in situ. With the aim of having an output like this. So this is actually recorded directly from the AIVR platform. Hopefully some of you will be familiar with it. What we're doing is we're searching by location using our map tool, and then we're selecting a piece of video. So all of the video data is updated and mapped accordingly. So you can pop your location in and you should hopefully be able to see some relevant information. And what you can then do is start interacting with that data. So where you're seeing faults, where you're seeing issues that you might not be able to see, and obviously a lot of these are situational. If you don't have access to site, this provides a really good way to circumnavigate any potential nasty scares when you actually then have to walk out there in the night. You can tag these, you can individually categorize them, and this can also be shared kind of widely. So where we can see here, we've got some damaged troughing. We're marking that up. We're taking measurements to understand where that is in relevance to the track, and also helping to kind of plan and inform our safety for any site visits that may be required for maintenance. So I'll just let that play through and we can see that in action as well. So a lot of the kind of forward-facing video gives you that really good context, and I think the benefit of having that constant up-to-date upload means that you're always getting the best overview of the environment, which means you're not having to repeat work. You can make those site plans and update them accordingly based on exactly what the environment is facing at that current time. So a little bit of insight there into AIVR forward-facing. One of the next steps that we've kind of gone to capture data is the AIVR focus system. So there's a couple of examples of the outputs just on the right hand side there, but this is a line scanning video system. So really high resolution imagery of the track and the forefoot that fulfills a number of different discipline purposes, but gives you that kind of really high resolution insight that you need. We've got an example of that in practice here. So this is again within AIVR. We can see we've got our rail inspection interface. All of the position is applied on the left-hand side, so you know exactly where you are in the network, and you've got a number of different tools in which to navigate through that imagery, so you can get a real close-up view of the infrastructure, any track furniture, and obviously the rail. So here we can see we're zooming into a crossing. We can really assess the quality and the condition of the rail at this point. We do also have a number of different capabilities there that actually enable us to automatically navigate through. So detecting crossings and being able to see that information intuitively, which I'll go on to in a little more detail. But as we can see, this first step is really crucial to actually giving you the ability to see what you need to see and taking it from there. So our next step is AIVR OLE. So this basically looks at all of the overhead line equipment and how we can capture that and again give you that context that you need. It's often difficult on site, especially on a night visit, to get a really good clear overhead view of the line, especially, you know, it is a live and dangerous environment. We want to make sure that we can give you the best kind of contextual analysis of that system without having to put anyone at risk or danger. So we can see here just a quick example of that data in action. We've got our pantograph monitoring camera here. So this is actually mounted on top of a in-service vehicle, so a 390 with Avanti West Coast. We're basically zooming in, aligning that with the position of the vehicle on our map. And what we're also doing here is using the technology to understand where we've got known overhead line assets. So we can line up that video data and get an understanding of what the infrastructure is and kind of how we're working with that as well. And finally, we're just going to look at thermal video capture as well. So this one is is a lot more in depth, being used a lot in kind of southern regions to look at conductor rail and electrified rail, but effectively looking beyond the visible spectrum. So how can we identify issues that we might not be able to see on site? So again, advancing that kind of technical capability to not only support existing work, but actually enhance your workflows by enabling you to identify issues before they even become an issue effectively. So just a quick example here of what we're doing with AIVR Thermal. You can see there's a lot of little boxes that are popping up there. That's some of our machine learning work that's at play, which we'll go into in a little bit more detail on the next slides. But effectively giving you that real thermal range of the rail and helping you to predictively maintain and identify risks effectively. This is all then shown again within the AIVR platform, enabling you to access that in a bit more of a dynamic way. So where we have thermal hotspots, you're able to view observations of that same issue, so you can assess change and monitor any risks over time as well. So now that we've harnessed all that data and we've worked with our partners to effectively install equipment and use different technologies to actually make that data accessible, whether it's with our own technology or actually maximizing on what's already there. Our next step in the process is how can we draw further intelligence and power up that data? So there are a couple of different ways in which we do this, but what I wanted to do was give a bit of a high level of kind of how we do so with mostly AI. Another buzzword as part of Rail's digital journey, but there are real benefits of using AI in standard kind of workflow practices, which hopefully we'll go through and you'll see those as we run through the technology. So this is just a little bit of an overview of how we work with the industry and how we work with our partners to actually understand where they might benefit from AI or where they may benefit from machine learning practices, to understand how you can further enhance efficiency and safety from the existing data and data sets that are available. So the key point for us is understanding where do we need to start. Outlining priorities and defining those requirements is a key in any sort of automation process, or understanding where we need to meet you in your digital journey. That also then informs actually how do we start? So what is it that's required in this particular requirement? So whether it's building a machine learning model where we're going to automatically detect issues, we'll need to start assessing and marking up data. So using all of that harnessed information and then applying further intelligence to it. And that helps us build a basis for creating that model and then also moving on to iterating it. So we always continue to iterate once we've got that base model of understanding and we've started to see some initial outputs. So whether it be we've found a fault on the line and we want to monitor it over time, we'll see where else we can find that particular issue or asset. We'll work with the end user to keep refining and training that set. And then that will take us through to our kind of final stages where we'll continue to develop and enhance that and align that with end user requirements. So do we need a reporting output from that? How can we basically inform end users further where we've started to see any potential issues? And the key thing that is really important as part of any of these phases and any application of AI in the industry is informing user insight and experience. I mean, I don't come from a rail background. I also didn't come from a technology background before I started this job. So I was very much at the mercy of our technical colleagues, but understanding kind of the key expert experience from the rail users and the rail industry means that we can actually develop technology that is going to benefit it in the most in the best ways. So that's kind of interwoven throughout any process and really critical to developing that powering up element. So we've just got a bit of an example here of some of the outputs in AIVR already. Some of you may have seen some of these. This is just a lot of our standard kind of AIVR detections. So we can see we're detecting points, scrap rail, issues like graffiti, signals. So whether it's kind of existing infrastructure or potential issues that are impacting the infrastructure, powering up is all about building your insight into that and intel into that environment. So it's all about supporting existing knowledge and where can we fill in the gaps where there may be missing information. So I wanted to showcase that by kind of identifying a bit of a process. So this is just an example of one of our recent projects where we've basically detected balance weights in visible imagery, and we're understanding how climate impacts can actually impact the position of that balance weight, which then means we've got risk of overhead line potentially being over slackened based on hot temperature. So again, we start at that initial starting point. What are our priorities? What are our objectives? We start finding the balance weights first, and then we keep continuously building a model to automatically detect those assets. That then pulls into our observation stage. Once we've found an asset, how many times can we see it in continuing data? Can we see any changes? How does that then feed into our prediction model? So if we understand and have a number of observations on a single asset, how can we understand its behavior and how can we start to predict it? So we build a basic prediction model, and then from that model, we can start to measure the performance of the asset. So here on the left-hand side, you can see we're basically tracking that position of that balance weight in that asset as we go through time, which enables us to build a standard or what we expect. And of course, that's all informed by end user experts who know exactly how these assets should be and what they should look like. So we build effectively a safe zone and a risk zone. And we kind of we visualize that, and we enable users to see where the position of that asset is, and then start to map that in the system as well, so you can navigate through those issues really effectively. And the endpoint then being the output. So this is just an example of that now in practice. So we can see here we've got a detected balance weight. We've given it an issue reference there, and we've built that safe prediction model zone based on all of that harness data, where we've understood where that asset should be dependent on different temperatures. And we can review that in a nice intuitive user interface. So we can run through a number of different observations in a really short period of time. So enhancing OLE resilience and kind of monitoring techniques. A second example of how we're doing that is actually through one of our new projects. So this is DepotMate. So we're effectively using the same types of technology that we have in AIVR built on the train, except we're moving it off the train, and we're looking at vehicles as they're passing to understand how we can build performance reliability and assess the asset effectively and understand, are we monitoring our rolling stock and keeping those depot workers safer as well. So again, we've got that phase by phase development. So we take the original raw temperature information from the thermal video. Then we've isolated that top 5% hottest region to give us our kind of expected areas. And then we find contours of each hot section, and basically anything below an expected temperature threshold is discarded to give us the final output, which is just on the right hand side there. So that's the detection that we're actually looking for, and that helps us classify and look for those assets specifically. So we can see here again just a bit more of a formal output of that. So on the left hand side is kind of the end point of a model like this, where we'll actually look to give condition analysis to understand what the actual asset is and not just its temperature read, to give more context and inform those maintenance regimes in a much more dynamic way. So we've got a bit of a case study here of that in practice and how that technology actually works kind of in the real world. So we can see an example where an AIVR thermal detection was sent out, and an alert was sent out to end users, where we basically found a hotspot or an exceedance, and this correctly identified that there was an issue that needed responding to. So it was sent with images and location details. The fault was immediately reported and triaged, and then the track engineering team were able to attend site safely, knowing exactly where the issue was and what the risk was. And they found that it had overheated and welded. So they were able to kind of make those maintenance decisions really quickly by having all of that information already powered up and provided to them in a nice simple package. So a really good example there of how that's kind of building that efficiency and enabling us to deliver more maintenance at a much quicker pace. I just wanted to touch back on some of the focus data that we looked at earlier. We've got a really mature model now that's looking at kind of the general condition and assets of the track and track furniture. And I think this video really well represents just how quickly we're now able to navigate through the network based on assets. So here we're just looking at joints. So we've automatically detected these joints, building a model in the same process that we just ran through previously. So building a number of different detections through a number of different training sets, and then using using that kind of data harnessing, so using the different types of sensors to review different angles of the track, to understand that condition and understand what kind of maintenance position that infrastructure is in. We've even further matured that now as we're building more intelligence and learning more from our end users as to why it's important to see this information and what more information might be required, to enable us to actually filter through and find faults. So we can see here again, another example is where we're detecting crossings. Users can literally jump to individual crossings across, miles and miles of data. So really increasing that efficiency and boosting the data that's already being captured and is already existing. And we've just got another quick example there of how the AIVR focus data is being used in the real world. So we can see here where we've been detecting positions of joints. Another way in which we're kind of powering up that data is using additional data sources. So here we've got a track geometry system. So what we're trying to do and work with end users to do is understand how those systems can be aligned to give you the best information that you need. So here we can see there was a detected dip in the track geometry. That was then aligned, a user logged in and aligned that with the imagery, and they could see that there was basically an issue with that joint. So they were enabled to report that fault immediately without having any kind of additional on-site triage. They could do it all from their desktop. And then that was basically mitigated and rectified in a really quick and efficient way. So a really good example of kind of how that technology has come in and enabled that collaborative working. So just a bit of a summary then of kind of why it's important and why we think powering up data is that next phase in the journey. It helps you find and resolve issues really quickly and efficiently. So it means that time is being used really productively and safely as well as also actually giving us a bit more of a map of the network. So as we mentioned earlier, trying to fill in those gaps where we potentially aren't able to get to the site, or we may not have good coverage of an area in our existing asset databases. So basically building up that infrastructure and network map. And then also kind of the critical one is how do we then enhance and inform further work practices using that data? So enabling you to kind of build reporting mechanisms where you're already capturing or analysing information. So that takes me on to step 3, which is just one of the kind of final phases of what we see as the full digital journey. Obviously, we understand that different organisations have different needs, and some may be a little bit more advanced and maybe adopting technology in a really quick way, and they're just looking to actually understand how can we use technologies together to give you the best information, whilst other organisations may be at those first beginning phases. But either way, this is kind of the end point that we would like to get to, and specifically want to build digitisation into that kind of strategy, is boosting workflows and improving efficiency. So we see that as actually kind of working really collaboratively. So understanding how we can use elements of our technology and align that with other existing technologies. We don't want to be a kind of one-fits-all technology. We want to make sure that we're actually maximising some of the existing capabilities that are already out there, and that other organisations have taken years to really refine and build. So how can we kind of fit in and support just at the parts of the journey that we're needed for effectively? And one of those ways is using kind of digital reporting capabilities. So within the interface, within the AIVR platform, you're able to export that information. So once a user's they've gone through that user journey, they've marked up all of their assets, their infrastructure, they know of all the faults that they've been able to see using that data, or potentially through using that the AI services that are available. Now it's about actually doing something with that information. So exporting that as a PDF, sharing that collaboratively, or feeding it into kind of any work arising forms. We think the kind of key benefit of this is actually giving you a visual output. It really sets context for what work's needed and also kind of what the state of the infrastructure is. So having that in one sort of easy to digest output is always kind of really useful. And it also looks nice for someone like me who has no idea of what's actually going on in the infrastructure. So we've got a couple of examples of how we're doing that here. So in a couple of our projects, we're looking at how we can use our existing data and data gather information from some of our end users to build kind of condition monitoring reports. So where we're starting to power up and detect different assets, how can we actually then intuitively track those conditions and kind of feed that back into the teams that deliver that maintenance. So the ballast condition, ballast monitoring conditions, for example, is effectively looking for kind of high or low severity areas where we're seeing minimal ballast. We know that there needs to be kind of ballast replacement, or we can see that there's existence of wet beds. This is all kind of pre-populated from the platform and then delivered as an output to give users a really kind of handy overview of what that whole system and petabytes of data is actually creating, and then enabling that to kind of feed and trickle through into the actual on the floor practices. And another way in which we're doing that is also using kind of rail troughing condition monitoring. So where we're seeing issues with troughing, if there's missing lids, there's exposed cables, we can see new troughing lids and their composition. How can we actually then capture that in a digestible way if we're covering sort of miles and miles of data? So looking at sort of assessing the conditions on the left and the right, and giving again a visual output of that. Another way in which we're actually kind of trying to build in that workflow aspect. So we've got the data, we've got those ML outputs. Now, how can we feed that into an actual digital workflow? Is with basic visual inspections. So this is just an example of how we've kind of modified the AIVR interface to fit with existing sort of track worker modules and track worker operations. So here we've created a digital inspection form. So this all gets pre-populated in the platform. So where users create markups, they can see issues or faults. They can do so kind of in one handy interface, and then basically pre-populate that into a single online form that can then be reviewed and accessed externally as well. So we can see here we're looking at an issue kind of from two perspectives to define exactly what it is we're looking at. Again, giving you and building that insight. And then finally, when we're happy with kind of what we've created from that, we can print that report and export that into something useful. So that's a pre-populated TEF form there that aligns with kind of all the compliance and the processes at hand. And we can see an example of that in practice. And then finally, also how we can integrate. So where we've discussed using the existing technologies that are at hand, it's actually then building that aspect of the AIVR technology into that kind of ecosystem. So whether that's through aligning with existing Power BI or huge kind of data banks, we've created widgets that can enable you to kind of review up-to-date imagery from your locations, so you can track all of your additional data sets, but also get really good contextual imagery, and again quickly assess where there might likely be problems. And another quick and easy way we've done that, and we've found has been really successful with some of our end users, is setting up a quick integration link, what we call find links, where users can go from one system through a URL and it will basically send you into AIVR to have a quick look at any available data in that location. So again, trying to use the data and systems that we have at hand and not kind of create those siloed environments where data is sat or potentially not being used to its full potential. We want to fit in on those areas of the journey and make sure that we're really underlining the benefits that need to be gained from any information that's being captured. So just a bit of a roundup then of kind of what that journey is and why we think AIVR's well placed to kind of support different organisations' digital journey. The key being, how can we future-proof? So how can we future-proof the rail and the rail industry to basically understand what it is we're looking at over the next couple of years and maximise the assets that we already have instead of kind of look for costly improvements. So just a few benefits here of actually how can we use digital lineside inspection technology to reduce costs. The critical point, of course, being how do we reduce boots on ballast inspections and how can we ensure safety of our workers whilst also enabling the best efficiency for rail passengers and freight. So we believe that kind of filling in on those parts of the digital journey and making sure that each of those elements of harnessing critical data, bringing intelligence from that data, and then using that data to inform how we work and how we work with the industry is kind of the key approach of doing that. And we think that the main kind of output of that is through collaboration. So working with a number of different industries and a number of different technologies to ensure that we're basically pushing the industry forwards instead of falling behind, and creating a more digital future. And just to round off by saying that the AIVR and One Big Circle are here to support your journey. So we've got a few examples here of just kind of how we've been working with the industry over the kind of last 6 years, and just some of those success stories, and how we hope that we can continue to deliver those elements of that technical and digital journey to ensure that everyone can work in a safer and more efficient way. So whether that be capturing, whether that be informing, we want to make sure that we're here to support that journey. And just a quick round off just before we go to kind of questions. If you'd like to find out a little bit more about how we're using all of those aspects of technology to meet you on your journey, we will also be exhibiting at Intertrans this year. So for anyone that is going to be in Berlin and would like to chat to us more, or potentially seen some of the technology here today and thinks that could help you create your digital workflows, please do visit us. We've got a stand just featured on the right hand side there that Anna's very kindly put together. So we'll be really open to talking to you more about kind of how we might be able to help, and how we might be able to align with some of your existing technologies. So thank you very much for listening. I've just popped a couple of details there as well if you'd like to ask any further questions kind of after the session. I know we're going to have a quick discussion now, but please do feel free to get in touch. We'd love to hear how you found today, and then if there's anything that we can potentially help you with. Thanks, Les.
Brilliant. Thank you very much, Lydia. Thank you very much, Anna. That was really interesting, but really insightful. Thanks a lot. So over to questions. Can I can see that there isn't a great deal in the chat pane. So can I invite if anybody would like to ask a question, would you like to raise your hand? And I'll come directly to you. And while people are thinking about that, I've just got sort of one thought, Lydia. In terms of coverage, you showed lots of different areas of the country where you had data sets, and I'm just wondering how wide the coverage for your system is, and how old the data is in those areas, and whether there are any areas, geographic areas, that you currently don't cover. Like, for example, do you cover Northern Ireland?
Yeah, so we've managed to kind of establish a really good coverage of the network, and that's mostly through working directly with the routes and regions in kind of the UK network. So currently within the platform, we do cover over 90% of routes in the kind of 5 Network Rail regions. So that's obviously Scotland, North West and Central, Wales and Western, Southern and Eastern. We're always looking to basically expand on how much data we're able to either ingest or capture based on each of those routes. So some areas, obviously we're all aware is there's devolution in the industry, and we want to be able to fulfill kind of the existing regional requirements. So some may be working with us to kind of boost the capture element, while other areas are already capturing data and are kind of working more on collaborating to sort of power up that data with AI. But on the whole, we do have 90% coverage. The regularity of the video is dependent on, again, kind of the route and region, but the majority of video data you'll see in the platform is under 6 weeks old, with some areas we're covering kind of daily or weekly. So obviously that's kind of our key target, is boosting that frequency of video and information that we're able to make accessible, with a long-term goal, obviously, of trying to get as much capture from passenger services as possible. To date, unfortunately, we're not currently active in Northern Ireland. We have done kind of some initial assessments, and it's definitely, you know, a really transferable technology. So should there be opportunity to start building what we've built kind of in Network Rail's nations, then we can definitely take that elsewhere. So yeah, we're really open to the opportunity to work in Northern Ireland and Ireland, and hopefully, yeah, we'll be able to maximise on that when we're in Intertrans, and kind of build those conversations as to how we can start that digital journey in those territories.
Thanks, Lydia. So just as a follow-up then, are there any, you're at Intertrans, it's an international exhibition. Are there other regions outside of Great Britain mainland that you're currently operating?
Yeah, so we have a partnership with a company called Railworks, who are based in the US. So we've done some initial trials over there with different operators, and we've delivered a number of different international trials in the Czech Republic, Lithuania, Australia. Obviously, again, part of kind of our focus of this presentation actually is supporting at the different stages of each organisation's journey. So we're at a stage now where we're really learning kind of which territories are at different stages and sort of understanding where we can fit in. So yeah, a lot of work to be done, but there's been some initial outside of the UK, which is really promising and exciting.
Okay, brilliant. Thanks for that. I can see we've got a question coming on the chat from Jake Gaskell. Thanks for your question, Jake. Jake asks, how is the train position calculated when in an area with no mobile signal coverage, such as a tunnel?
Yeah, so we do a number of different kind of calculations. So it's dependent on the kind of device that we're working with. So we have the ability, if there's already kind of a positioning system on board the train, we can tap into that and pull a data feed from that. So on the AIVR Focus system, as an example, we do tap into the kind of speedometer and tachometer that's available on the train. We also work with additional kind of third-party partners. So working with Machines with Vision, and we've got a really good collaboration with them using their positioning system, RailLock, on some of that kind of AIVR Focus data. And that basically, yeah, gives a really high accuracy positioning in the track imagery. We do have a number of different ways in which we kind of manage the GPS loss. We kind of track it based on the INM, and then also where we have downtime, we tend to buff the imagery so it uploads correctly when we regain that signal. But for some of the more robust installs, so where we've got a permanent install for a visible camera, we try and enhance the kind of the signal and GPS offering that we have with those systems as well. So as well as also kind of working towards using automation. So how can we actually use landmarks as a positioning reference? Now that we're getting sort of all of that information and we're working with petabytes of data, where we've got run on run, information of known assets, how can we use asset information, visible detection, and then also GPS positioning to actually give us kind of a one true position? So there's a number of different mechanisms that go into the positioning that our tech team will be able to give, yeah, a much more in-depth explanation of. But yeah, we look at kind of all of the available data to give us the sort of best guiding position.
Brilliant. Okay, thank you very much. Are there any other questions? Would anybody else like to type something in the chat or come off mic and ask your question? Just raise your hand and I'll come directly to you. Paul Evans asks, my work covers the whole rail corridor, not just the area around the tracks. Is there a plan to have side-facing cameras as well as the front and back and the up and the down?
Yes, yeah. So we do, pressed for time, apologies. I would have featured it in the presentation otherwise, but we do have a system called STREX, which stands for structural examination. So using the yellow box that I featured at the start, where we can house multiple different sensors, we're basically using two visible cameras that sort of look. I'm doing this as a bit of a boss-eyed view, but look left and right to effectively give you the review of any kind of surrounding structures, embankments, any potential vegetation that's kind of on the side of the corridor as well. So that data is out there and being collected. It's currently installed on one of the visual inspection units, which runs in Easton. But we do have additional hopes to kind of further roll out that kind of structural examination data as well. But yeah, happy for you to get in touch. If you email the inquiries email, I can send you some examples of what that data looks like, and hopefully it will fulfill your needs, and we can chat about it further.
Thanks, Lydia. And another question from Simon Bjork. Simon asks, the monitoring of the balance weights is interesting. Do you have a roadmap for other elements of overhead line key parameters that could be examined?
Yeah, interesting. Yeah, the balance weights one was a really exciting project, and I think a good demonstration of how many different data sets can kind of feed into like a ML output. We are trying to look at how we can expand our existing offering to fulfill kind of OLE requirements. So one of those actually being how can we use our existing thermal technology and reconfigure that system to understand kind of heat profiles of the OLE. So where there's kind of, overheating transformers, potential known risk assets, how can we inform that through thermal data? We are also drawing kind of a number of different measurement detectors of where we have droppers, where there's potential impacts to the OHL structures. So if there's infringement, as an example, obviously infringement and things like that are a little bit more kind of seasonally based. But yeah, effectively the kind of process we go through is once we understand what the requirement is, it's basically assessing the data that we have to see if there's a visible or kind of visual solution to it. So yeah, we're basically looking to understand what those parameters are and working with our partners in kind of the industry to understand what it is that that could be done, and then using the technology that we have to build on that offering. So any suggestions you have, we'd be really interested to hear. I know there's a lot more that can be done with kind of OLE monitoring, so we'd be really interested to hear that.
Thanks, Lydia. I've just noticed that Adam Williams has posted a comment. He says, "Don't forget about the Crave sub-project." Does that mean something for you?
Yeah, so yeah, Crave's been a really successful project. So that's cable route automated visual examination. There's too many acronyms, I'm so sorry. So we referenced it slightly in the earlier slides, but yeah, we're basically looking at cable route monitoring and how we're getting those kind of cable route troughing reports. There's a lot of work that's being done there on kind of building that initial detection, but then actually refining it to get more of a condition analysis, which there's a lot of work that goes into that, and a lot of that is informed by our end users. So yeah, Crave's been a really exciting project of kind of how we can further inform the system with sort of the knowledge that lives in all of the rail experts' heads. So yeah, definitely worth a shout out.
Fantastic. Okay, brilliant. Thank you very much. Well, I think we've come to the end of our list of questions now. Oh, I can see that someone has raised their hand. Berber, you've raised your hand. Would you mind coming off mute and asking your question, please?
Yes, just was thinking to ask one more question. So thanks, Lydia, for presentation, and thanks for organizing all this. But was thinking about the from the point of view of designers as a input. So let's say even every project running now, iTwin, is all based on federated models. So how this would be cooperation from the products that AIVR could produce, and without needing any additional work to be done, which could be go straight into federated models. Maybe you have some cases you can mention, or just quick overview.
Yeah, it's something that does get raised quite a lot, is how kind of the existing visual data can feed into the design process. Obviously, we understand there's a lot of benefit in having a bit more of an up-to-date and kind of continuously refreshed view of the existing environment, and how important that is for design planning. Currently, to date, we haven't done any kind of really heavy integration with an existing sort of 3D modeling system. We have done kind of an initial development of can we overlay 3D models in the imagery. So we use a signaling model that's available within the platform that can basically be placed and used as a reference point. But it's something, again, that really fits into that story of that kind of digital journey, and sort of where we can fill in at the right point. So we're always really interested to hear how we can kind of support existing design models, and whether there's benefit of sort of having a direct integration from AIVR into whether it's CAD or other types of design models. So yeah, happy to send more information on the system and potential opportunities for that.
Thank you. Any more questions? I can see we're already starting to lose people. Wonderful. Okay, well, in that case then, once again, thank you very much, Lydia. Brilliant presentation. Thank you very much for your insight in the answering the questions. Really detailed. Thanks for that. Just for everybody else on the call, if you've got any further questions that you'd like to ask the speakers, Lydia's put up an inquiries email address there, but I'd also encourage you to use the PWI LinkedIn page. There'll be a dedicated discussions post just for this lunch and learn session. So please pop your questions or comments in there, and they will be answered and responded to, and also there'll be a record so others can see the conversation. And finally, just a reminder about what we talked about at the beginning of the Lunch and Learn. Please don't forget about the 140 challenge. Encourage all of your colleagues to take a look at that and participate. If you're not professionally registered yourself, please consider doing so. And finally, our next Lunch and Learn session will be on the 1st of October. And the title is Slab Track System IVES Superstructure Upgrade during Short Track Possession. So with that, I'll draw the session to a close, and thank you all for your attention, and I hope you found it as interesting as I did. Thanks. Bye-bye.
Thanks, everyone.